Converting a building into a school necessitates understanding the electrical requirements specific to places of assembly. In the context of electrical codes, a school is indeed classified as a place of assembly. This classification triggers specific regulations designed to ensure the safety of occupants, particularly concerning electrical systems. Existing BX cable, which is armored cable, within the building is a point of consideration. If the existing BX cable is in good condition, it does not necessarily have to be replaced with MC cable, which is metal clad cable. The determination of good condition is crucial and generally involves assessing the cable for any signs of damage, deterioration, or improper installation. Signs of damage include cuts, abrasions, or other physical harm to the outer armor of the cable. Deterioration could manifest as corrosion or degradation of the insulating materials within the cable. Improper installation could involve issues like excessively tight bends or support spaced too far apart, placing undue stress on the cable. It is essential to thoroughly inspect the entire length of the BX cable, paying close attention to connections and areas where the cable passes through walls or other structural elements. If the inspection reveals any instances of damage, deterioration, or improper installation, those sections of BX cable should be replaced. However, if the existing BX cable passes this inspection and is deemed to be in good condition, it can remain in service. Now, if any BX cable is replaced during the conversion process, the replacement cable must be MC cable. This stipulation is a key aspect of modern electrical codes, reflecting the improved safety characteristics of MC cable compared to BX cable. MC cable typically incorporates a grounding conductor within its armor, providing a more reliable grounding path. It also tends to have better resistance to physical damage and environmental factors. The decision to use MC cable for all new or replacement wiring aligns with the objective of enhancing the overall electrical safety of the school building. In practical terms, this means that any new circuits installed during the conversion must be wired using MC cable. Furthermore, if any existing BX cable is extended or modified, the extension or modification must also be performed using MC cable. The transition from BX to MC cable must be done correctly, ensuring proper connections and grounding to maintain the integrity of the electrical system. When working with electrical systems, it is essential to adhere to the National Electrical Code, NEC, as well as any local electrical codes that may be in effect. These codes provide detailed requirements for the installation, modification, and maintenance of electrical wiring systems. Consulting with a qualified electrician is highly recommended to ensure compliance with all applicable codes and to ensure the safety of the electrical system. The electrician can conduct a thorough inspection of the existing wiring, assess its condition, and make recommendations for any necessary repairs or replacements. They can also ensure that all new wiring is installed in accordance with code requirements and that the electrical system is properly grounded and protected. The NEC addresses various aspects of wiring in places of assembly, including requirements for emergency lighting, fire alarm systems, and other safety-related equipment. It also specifies requirements for the type and size of conductors, overcurrent protection devices, and wiring methods permitted in these locations. Some specific areas to consider in the NEC include Article 518, Places of Assembly, which covers general requirements for wiring in places of assembly, Article 520, Theatres, Audience Areas, and Similar Locations, which addresses wiring in theatres and similar venues, Article 700, Emergency Systems, which covers the installation and operation of emergency electrical systems, and Article 701, Legally Required Standby Systems, which addresses systems required by law or other regulations. Furthermore, the NEC has tables for ampacity, such as Table 310.16, which provides allowable ampacities of insulated conductors rated up to and including 2000 volts, based on their insulation type and ambient temperature. These tables are crucial for determining the appropriate size of conductors for various circuits, ensuring that they can safely carry the intended load. Additionally, Article 250 covers grounding and bonding requirements, which are essential for preventing electrical shock hazards and ensuring the proper operation of electrical equipment. The NEC is a comprehensive document, and it is imperative to have a thorough understanding of its provisions when working on electrical systems and places of assembly. In summary, when converting a building to a school, which is a place of assembly, the existing BX cable does not necessarily need to be replaced if it is in good condition. However, any new or replacement wiring must be done using MC cable to meet modern electrical code requirements and enhance the safety of the electrical system. Consulting with a qualified electrician and adhering to the NEC are crucial steps in ensuring a safe and compliant electrical installation. It is also important to note that the specific requirements for electrical systems in schools may vary depending on local codes and regulations. Therefore, it is essential to consult with the local electrical inspection authority to determine any specific requirements that may apply to the project. The local authority can provide guidance on code interpretations, permitting requirements, and inspection procedures. They can also help ensure that the electrical system meets all applicable safety standards. The focus on safety in places of assembly stems from the fact that these locations typically have a high density of occupants, increasing the potential for accidents and injuries. Electrical hazards can pose a significant risk to occupants, particularly in emergency situations. Properly designed and installed electrical systems are essential for minimizing these risks and ensuring the safe evacuation of occupants in the event of a fire or other emergency. In addition to the specific requirements for wiring methods, the NEC also addresses other aspects of electrical safety in places of assembly, such as the installation of ground fault circuit interrupters, GFCI, in wet locations, and the use of arc fault circuit interrupters, FSI, to protect against electrical fires. GFCI devices are designed to detect small imbalances in electrical current, which can indicate a ground fault. When a ground fault is detected, the GFCI device quickly interrupts the flow of electricity, preventing electrical shock. FSI devices are designed to detect arc faults, which are a common cause of electrical fires. Arc faults can occur when electrical current jumps between conductors, creating heat and potentially igniting nearby materials. When an arc fault is detected, the FSI device interrupts the flow of electricity, preventing a fire. The NEC also includes requirements for the labeling and identification of electrical equipment and wiring. Proper labeling is essential for facilitating maintenance and troubleshooting of the electrical system. It also helps prevent accidental contact with energized equipment. In addition to the NEC, other codes and standards may also apply to electrical systems in schools, such as the National Fire Protection Association, NFPA 70E standard for electrical safety in the workplace. NFPA 70E provides guidance on safe work practices for electrical workers, including procedures for lockout/tagout, personal protective equipment, and arc flash hazard analysis. Compliance with NFPA 70E is essential for protecting electrical workers from electrical hazards. The conversion of a building to a school is a complex project that requires careful planning and attention to detail. Electrical considerations are a critical aspect of the project, and it is essential to ensure that the electrical system meets all applicable codes and standards. By working with qualified professionals and adhering to the NEC and other relevant codes, it is possible to create a safe and reliable electrical system that will serve the needs of the school for many years to come. The inspection of existing BX cables should include a visual assessment of the outer armor, looking for any signs of damage or corrosion. The armor should be intact and free of any breaks or punctures. The cable should also be securely supported and properly terminated at junction boxes and other electrical equipment. If any damage or defects are found, the cable should be replaced with MC cable. The installation of MC cable should be performed in accordance with the NEC and the manufacturer's instructions. The cable should be properly supported and secured, and the connectors should be properly tightened. The grounding conductor in the MC cable should be connected to the grounding system to provide a reliable grounding path. The transition from BX cable to MC cable should be made in a junction box or other enclosure. The BX cable should be properly terminated in the box, and the MC cable should be connected to the BX cable using appropriate connectors. The grounding conductors from both cables should be connected together to maintain the integrity of the grounding system. In addition to the requirements for wiring methods, the NEC also includes requirements for overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from excessive current, which can cause overheating and fires. The size and type of overcurrent protection device must be appropriate for the circuit being protected. The NEC includes tables that specify the maximum allowable current for various sizes of conductors. It is essential to select overcurrent protection devices that are rated to protect the conductors in the circuit. The NEC also includes requirements for the location and accessibility of overcurrent protection devices. They must be readily accessible and located in a safe place where they can be easily operated and maintained. The electrical system in a school should be designed to provide adequate power for all of the school's electrical equipment and lighting. The load calculation should be performed in accordance with the NEC to determine the total electrical demand of the school. The service entrance and distribution equipment should be sized to accommodate the total electrical load. The lighting system in a school should be designed to provide adequate illumination for all of the school's activities. The lighting level should be in accordance with industry standards and the recommendations of lighting professionals. The lighting system should also be energy efficient to minimize energy consumption. The electrical system in a school should be properly maintained to ensure its continued safe and reliable operation. Regular inspections should be performed to identify any potential problems. Any necessary repairs or replacements should be made promptly. The electrical system should also be tested periodically to verify its performance and ensure that it meets all applicable codes and standards. The conversion of a building to a school is a significant undertaking that requires careful planning and execution. The electrical considerations are a critical aspect of the project, and it is essential to ensure that the electrical system is designed, installed, and maintained in accordance with all applicable codes and standards. By working with qualified professionals and paying close attention to detail, it is possible to create a safe and reliable electrical system that will serve the needs of the school for many years to come. Furthermore, consider the integration of modern technologies and energy-efficient solutions during the conversion. This could include incorporating LED lighting with intelligent control systems, installing occupancy sensors to reduce energy waste in unoccupied areas, and utilizing smart building management systems to monitor and optimize energy consumption. Implementing these technologies can not only reduce the school's operating costs but also contribute to a more sustainable and environmentally friendly learning environment. As part of the electrical system design, it is crucial to plan for future expansion and technological advancements. Consider incorporating spare capacity in the service entrance and distribution equipment to accommodate future increases in electrical demand. Also, consider installing conduit and wiring pathways that can easily accommodate new wiring and technologies as they become available. This will help ensure that the school's electrical system remains adaptable and up to date for years to come. In addition to the technical aspects of the electrical system, it is also important to consider the aesthetic aspects. The electrical system should be designed to be visually appealing and integrated seamlessly into the building's architecture. Wiring should be concealed whenever possible, and electrical equipment should be located in discrete areas. The lighting system should be designed to create a comfortable and inviting atmosphere for students and staff. Finally, it is important to document the electrical system thoroughly. Detailed drawings and specifications should be created to document the location of all wiring, equipment, and controls. This documentation will be invaluable for future maintenance, troubleshooting, and modifications to the electrical system.